So welcome to handling input for desktop users in a delightful way. That's always the awkward beginning of any talk here, right? So my name is Patrick Martin, and I'm a developer relations engineer on Google Play Games, or Android games.
Hi, everyone. Thanks for coming. My name is Shen Shen. I'm the developer relations engineer in Google, working on multi-platform gaming. I hope most of folks here agree that maybe multi-platform gaming is the future. In the previous session, we talked about how to bring more users to your game across different surfaces. And this session will be slightly more technical, which we're going to focus on improving the game experience.
All right, so yeah, we're here to talk about input on Android and how to make your game great. So what do we mean by this? So Android runs on a variety of devices. I actually said like all form factors in my original script, and they're like, do you really mean all? Can you prove that? So it's a variety. But some people think, hey, this might make it hard to target Android, right? Like, do I really need to support mouse and keyboard on a watch or something? But I want to try to posit throughout this talk that the neat thing about Android is you can write your game code once, like your logic, your physics, your billing, ads, whatever, and then experiment with it across form factors. Like maybe your phone game will make a good watch game or would be awesome on like a TV. Android is a great place to do that sort of experimentation. So, of course, today we're focusing across Android, and that was literally a picture of my desk, so like I'm weird. But, yeah.
Yeah, we've broken this talk into roughly two sections. The first is what to do. So basically, we couldn't cover all the game engine, how they did input, so that's remained the things on the higher level. Then the second session would be how it's actually getting done. So we will dive into a bit while the input actually happens in Android and how they moved into your game. With that, let's look at what to do with all kinds of Android input devices.
All right, so if you reach into your pocket, you'll probably have a phone. And I was supposed to tell you to silence them at the beginning of the talk. Totally forgot to do that. But when you see the phone, you'll find like this black rectangle with a touchscreen on it. And this is kind of the default state for Android input. If you're here for a talk on Android game development, you probably know how to like build a game for one of these. So you don't need me to go over much outside of just remind you that on touch event happens and you know the rest. If you don't know the rest, welcome to Android, and I would love to talk to you more after the session. I'm a DevRel because I love talking. They can't shut me up. So on the PCs and Chromebooks, though, you don't have a touchscreen. So if this default input mechanism does not work, which is like the mouse in this case, you can't reach up and touch the touchscreen and work around it. So for PC-like devices, we actually have a default touch emulation layer that's on by default. This means that mouse events come in on touch event instead of on generic motion event, and they have a tool type touch or tool type finger instead of a tool type mouse. You can turn that off, but
yeah, but this is fine for games like Clash of Clans by Supercell. Actually, Google Play Games is the first time they made this title available for all the PC gamers. And the compatibility layer just streamlines the porting effort. So they implemented their own generic motion events just for the mouse scroll wheel. Then the player can zoom in and zoom out to view the map. Other than that, they didn't change much on the mouse front. So they only just listen for the touch input, same as what they did for mobile. So, of course, you can just disable the compatibility mode to take the full advantage of by adding this hardware type PC to your Android manifest. On tablet and the phone, this has like no effect, but you should just remember to set require to false, so you can still get install on those devices, which is pretty important. But for on PC and Chrome OS, you just told Android, hey, I know what is the PC, I know I will work. So the compatibility layer just shuts off, and you get the mouse events to handle. Remember that you can still just wait for the on-touch events to trigger, but you can also listen to the generic motion events. Then you can get the other states, like the mouse hover states, scroll wheel, and of course, you can also get events through all the other mouse events, which means like left, right, middle button, and all the customer buttons. Yeah. I would assume the mouse input might not be that familiar to many Android developers. So let me warn some about the common mistakes. So I would suggest don't disable mouse just based on form factor or architectures. So users can basically hook up a mouse to everything. They can even USB or Bluetooth connect to a mobile phone. And we know some of the Chromebooks, they run on ARM. And remember that you might get from 0 to many events in one frame. So if you don't accumulate your mouse events, you might just miss subtle of the player's input. And if you don't clear your accumulator at the end, your mouse control might be drifted away when player just lets go of their mouse. And the mouse is much more accurate than the touchscreen. So especially, yeah, you are not blocking, the users are touching. So you shouldn't need to really smooth the input if you just handle it as fast as possible. And of course, player would notice that if you just skip a mouse update for a frame, or you filter out a small twitch, that is not recommended. And there's also a cool way to handle mouse is that you can capture the mouse to hide the cursor. With that, you will get the delta update rather than the absolute position of frame by frame. This is particularly useful for some of those like first-person camera games. But please don't use that just for implementing the custom mouse cursor. We have the API view.setMouse pointer icon and the view.onResolve pointer icon, which they generate downstairs much better.
All right, and with that, let's focus on mouse capture a little bit. So this is a game called Knives Out by NetEase, and this is one of the more popular Battle Royale games on Google Play Games. And if you're familiar with PC gaming, you probably recognize this control scheme. It's like the standard mouse look, right, to move around. Now, if you don't capture the mouse at all, obviously your mouse pointer would either run into the edge of your screen, and then you can't rotate and you die, or the mouse will go off the side of the window. You might accidentally send an email, and then you'll also lose your match, and this time be a little bit more embarrassed about that. So what you want to do is capture the mouse, which you can do in Android. So first you need a focusable view. They gave me a laser pointer. This is awesome. And the focus view is what lets you capture the mouse and handles the update. And then you call request pointer capture to actually handle the capturing event. And you can release it at any time by calling release pointer capture, right? And you'll want to do this for menus, like the main menu, pause menu. Maybe you're making like a MOBA or an RTS. You might leave the mouse normal for most of the game and then capture it for a specific ability or to like perform some action in the game. And then events come in on this captured pointer event instead of on generic motion event. This might be a little annoying at first because you're like, oh, another callback that I have to handle. But the nice thing about this is that you don't have to maintain state. You don't need to know if you're captured or not to know if you need to track deltas or absolute positions. And a few other notes on this. You may lose pointer capture at any time, so register a on-pointer capture change listener. This is because it's tied to focus. If your view doesn't have focus, you don't get the mouse. And then you don't want to do this on create because your view is not focused at that point. This really doesn't come up because your game usually launches into a main menu or something. Just when you're prototyping, right? Your first test, don't capture an on create. Now, mouse and keyboard, that goes together kind of like peanut butter and jelly, Sonic and Tails. It's the dynamic duo of PC game inputs, right? And the good news is, if you want to implement the keyboard with mouse, it's been supported since basically the beginning of Android, right? The Android G1 had a little slide-out keyboard on it. So there are no compatibility layers to worry about. There's an on key down and on key up, and they just work. And your engine probably already uses it already, at least for the back button. Now, the only things to really watch out for is on key down gets triggered multiple times. Usually this doesn't seem to cause issue because you're just looking at a binary, is it down, is it up, once you get into the game. And then you do want to make sure you pass unhandled events into the super and mark them as handled or not. And the reason why is the system relies on this for like some features, some accessibility, some other compatibility layers. So you just want to be a good citizen when handling the keyboard. And this will come into effect with controllers as well.
Yeah, let's talk about game controllers. game controllers are another great input device that, for game to support. You can find the game controller in the Google Play game, the icon itself. So of course, both Google Play games on PC and the Chrome OS devices, they support game controller as well. Many OEMs introduced those great mobile gaming controllers. And Android happens to have actually great game controller support. In addition to your typical 16-button dual analog game controller architect, Android supports like haptic, touchpad, gyroscope, and even setting the lighting color on some of the popular game controllers. There's also a great C++ native controller library I want to call out. We call it Paddleboat. That make it all easy for game devs. Now, for some reason, if you decide I don't want to use the native library, I don't want to use the Paddleboat, the game controller events would also come in on either the on key down or on key up for the digital button press, or on the generic motion events for those analog inputs. Yeah, it's just similar to like handling with mouse and keyboard in general. And I would be remiss if I didn't mention that Android actually supports game controller haptic, both via the Paddleboat we mentioned, but also is supported through the Vibrator API in managed code. So there's very few games really taking advantage of it, making many players thinking it's unsupported. But we do have a good sample app to play with. So we can check out our Android game sample on GitHub.
Right. So something to remember through all of this is that if a player can hook something up, it probably works on Android, right? If you plug a mouse into a phone, it works. A controller into a car. So I want to reiterate that you don't need to support everything, right? If it's not expected that a mouse works on a phone, don't make this like a P0 feature. But when you add support for like the PC platform, I would recommend you don't take out mouse support for phones as well. And you might wonder, why do this rather than if PC, use keyboard, else use touchscreen, right? This is easy. And part of it is user preference. If you're in the gaming community and have a pulse, you've probably seen flame wars of like PC and mouse versus like game controller on like forums and stuff. And you don't want your game to be in the middle of that, so just try to support everything. But there's also an accessibility angle. So if you go out to the Google Play Games booth out in the lobby, you actually see this Project Game Face that lets you control a game using your face for like differently abled gamers. And the thing is, if you require a user to move their face all the way over, then like blink to click a button, that is kind of an arduous process when you could just map open my mouth to spacebar or wink to the left shift. And that's much easier if you provide keyboard bindings for your players. And then as well, this is a fun project I did with my daughter. We built a game controller out of a cardboard shoebox with like a couple dollars worth of parts, and this is actually hooked up to a Chrome OS device. If I can do this with a 6-year-old, right? Imagine a dedicated gamer. This is like their hobby. If they're differently able, they could still make a controller that they would be able to use, and the only thing blocking them from playing your game would be whether or not you integrated controller support, right? So my advice is, overall, anything is better than nothing. But if you look at Disney Speedstorm, this is an excellent cross-platform kart racer. And GameLoft is actually really good with this in general, with Asphalt as well. When you start using a gamepad, it just starts using gamepad controls, like buttons switch over to press A and whatnot. Then when you use a keyboard, it switches back over to keyboard controls. And really, this is what we recommend for accessibility and user preference if you can. But again, if you can't do that, still just having like a toggle for the gamepad is very much appreciated for players who prefer that. And then I would recommend, if you're more interested in this topic overall, my colleague Emily Roberts has this awesome video from Google I/O 2021 just about how to handle the logic of switching and how to update your UI. It's for Chrome OS, but really applies across Android. And yeah.
Yeah. Now let's talk about what input would actually looks like in the low-level Android. I think this is especially relevant to our game devs, since you might not want those higher-level managed abstraction, or you just want to find out the shortest possible path from the single button press to your gameplay. So first things first, Android is basically Linux with a weird user space, but Linux at its core. And just like your Linux desktop, can someone remind me, is 2024 the year of Linux desktop? Nah. But anyway, you can find out all the input device and all the input events just on the dev/input. The best way to get an idea of what input events of any Linux or any Android device has is just to execute the shell command line, get events -p.
Right, and the fun thing with get event is that you can attach to one device and just see all of the inputs it's spitting out. So it can kind of feel like the Matrix, right? The person walking down the street wearing a red shirt or something. Same thing, you add -LT and you're like, oh yeah, I see absolute X position. I see like the south face button. This is, you can just inspect any device you plug in and see what's happening, see what's supported. But it turns out that as a game or app developer, you don't get to just listen to the dev file system and do what you want with it. You get these input events, either a key event or a motion event, depending on the kind of input. So let's look at what happens between the kernel and Java, and hopefully there's something useful here for y'all. So Android is open source, so I'll try to include breadcrumbs so you can look at this. This is not a talk for OEM, so I won't go in too much detail, but just enough to give you the idea of what's going on. And you can, of course, check me later, or if you're watching a recording, you can see if this still holds true into the future. So first things first, Input Flinger is kind of responsible for coordinating input across Android. And we have this Input Manager service, which as a game developer, I'm usually looking for the C++ layer. I usually have a cross-platform engine written in C++, and I bind to each platform. And it's convenient if everything's in that native layer. And at first, I might be a little put off because Input Manager Service is a Java class. But if you choose almost any random method in here, you'll see it just basically bounces into native. This code isn't important. Just the important bit is that little code here, a lot of code here, right? And you'll see this throughout. And the Input Manager service has these input readers. Now, these are what attach to the dev file system and do whatever. They'll detect a device, check its class, and create the input mappers. And these input mappers are what's responsible for actually sending information to your game that is useful for the game to do stuff with. This gets to your game via something called an input dispatcher. This dispatch is to a looper owned by your view root impl. You never override this, but it's part of the big collection of classes in the Android framework when you create your own activity and whatnot. This has a looper. This is something that keeps most Android Java threads alive. It basically while one's with a message queue so threads can communicate back and forth. Right? And then the very interesting part is input event receiver actually creates the Java object in your application space out of the native object. So at this point, notice that all the input logic has been happening in C++, and the Java gets created on top of it, which is really convenient for Java-based apps and whatnot. But for games, right, we kind of want to look at native stuff. So the input queue is kind of what processes the inputs in your app side. And the interesting thing about this is if you look at our documentation, it just says use the native bit, right? If you're going here, it has a full native interface, which, again, game engines use C++. Even if you're coding in Lua or C#, this is usually the shortest path. And it would kind of stink to redo a lot of the logic that's in the C++ inside your game as well. So I'd like to highlight native activity. So native activity, it's a little older, so we don't recommend it as much. The main reason is that it inherits from activity instead of app-compat activity, which isn't as compatible with newer libraries that use Android X, but we'll get to that in a little bit. But you'll see that right in its onCreate, it calls get window take input queue. And then as soon as it gets the input queue and the onInput queue created, it gets the native pointer and jams it into the C++ implementation. And then everything is input queue native. So you get event, you finish an event down here somewhere. There we go, finish event at the end, of course. This is all handled in native input glue, but I want to highlight that this is now a native pathway all the way through without extra buffering or extra logic that you have to duplicate. But it turns out that a lot of game engines don't do this for an interesting reason. This is the source code for input queue, and you'll see get native pointer is marked as hide. This just means it's removed from the public API until API level 33, so there's good news. At which point you can say input Q from Java, and you can do everything exactly like game activity. So if you're building your own game engine, this is kind of the fastest way to take all that native logic right into your game. Now, the downside of this is that since this was added in API level 33, this is Android T, you probably want your game to work with a phone that's a little newer than like 3 years old. So we have something else for you.
Yeah, let's check out the game activity. This is a newly introduced activity for game devs, which have certain advantage compared with native activity. It doesn't do anything that you couldn't, but it's just written for you. It inherits from the app compat activity, make it play nicely with all the existing Android library, and that you can still drive your core game logic gameplay code within C++. But yeah, even the game activity doesn't really get back sneaky past the API restrictions, so you still don't have the direct access to the A input queue. Game activity works by copying the relevant data into a buffer, then you can just swap it in C++ and act on. This is fine for most of games, but although it is sometimes make it a little bit easier to accidentally delay the input for one frame if you mess up some of the copy things. So just a reminder for those sensitive, input-sensitive games. Game activity also pairs well with Pedalboat to handle game controller, as we mentioned before, and also the game text input. That's a better way to handle the software keyboard for text input. Then you can forget those old tricks of how to hide a text editor off your screen. Yeah, I think that should be all we have time to cover for today. So remember, we first covered the fact that Android is varied across form factor, across which you can share code, but still you should do your best to polish your input experience for each form factors. Then we took a brief look at what different input device type are and how games should handle them. Finally, we check out what's inputs coming from on the system and how they are bubble up into your game.
All right, yeah, and hopefully with all of this, we've dispelled a little bit of the magic that hides underneath all the Android games. Maybe encourage you to prototype a bit more with different Android form factors along the way. With that, thanks for coming. If you have any questions, certainly see us. I guess we'll be outside this room as we can. There's also a great Android booth out there in the lobby for Google Play Games, which you'll be able to check a lot of this out and see what Google Play Games is all about. And then I think also I'm supposed to ask you to fill out a survey because it's awesome when we love surveys, or they love surveys. Someone loves surveys. So with that, thanks for coming.
Thank you.